Nitrogen composes 78% of the atmosphere equals nitrogen, 78. Imagine yourself the sky has the number 78 drawn in the sky. Unreactive BCS of the strength of the triple bond, 942 kJ per mole, that takes a lot of damage. J. Nitrogen can be used where an inert atmosphere is desired. Nitrogen equals inert atmosphere. 2 isotopes 14N and 15N. 14 and 15N. Hash protons, 7 hash protons, 7. Hash neutrons, 7 hash neutrons, 8. Abundance, 99.634% abundance, 0.355%. Notice, the proton stays the same for its isotropic form, but the neutron differs because isotope equals proton plus neutron, so all you need to do its mathematical equation. Just need to remember the abundance though. Ammonia. Ammonium ion. Ammonium ion is a common +1 ion, many salts are known. Solutions are weakly acidic due to hydrolysis. NH4 plus equals conjugate acid of NH3. NH4 plus H2O, NH3 plus HEO plus, acid base RXN. When ammonium is added, it will go back to ammonia. Ammonium salts can decompose when heated strongly. NH4Cl, NH3 plus HCl, this is consisted with an ammonia plus its acidic counterpart, HCl. NH4NO3, NH3 plus HNO3, this is consisted with an ammonia plus its acidic counterpart, HNO3. This is what you call an internal proton transfer reaction. Ammonium ion is reducing. Ammonium salts with oxidizing anions can decompose by oxidation reduction reaction. NH4 2Cr2O7, N2 plus 4H2O plus Cr2O3. Producing N2, H2O and Cr2O3, solid. NH4NO3, L, N2O plus H2O. In NH4NO3, you are producing N20 and H20. NH4NO3 is used as a fertilizer. NH4ClO4, engine of space shuttle. N3 equals nitride. 3 types are ionic, covalent or interstitial. 1. Ionic nitrides. Contains the N3 ion. Examples. The M's are metals. Men, M equals Li, the N's will have L. M3N2, M equals Mg, Ca, Sr, Ba, the N2s will have the Magna Carta straight barbershop. Formed by the direct union of elements at elevated temperature. Reacts with water to produce ammonia and its metal hydroxide. Lean plus 3 H2O, 3 Leo plus NH3. Al4C3 plus H2O, CH4 plus AlO3. Once again it is proton transfer. 2. Covalent nitrides. Formed with the nitrides. We are focusing only with boron and silicon. Boron nitrides. Bn analogues of benzene, diamond, graphite, Bn analogues of the bed graph. Some things to remember. Borazine has formal charges, while benzene doesn't have any formal charges. It will readily oxidize. Similar to that of a benzene in terms of its smell. Biphenyl. Structure of Bn graphite is slightly different because of its formal charges. With this, the opposite charges are gonna be on top of another. Regular graphites equals layers are offset. Bn graphite equals direct standing. Bn graphite equals thermally stable, can heat it up in a higher temp before it decomposes. Silicon nitride C3N4. Network covalent solid. Can be molded into a ceramic material. Very hard material. Gallium nitride. Semiconductor. Isoelectronic to that of a carbon. Blue LED is made of gallium nitride. Used to make some light-emitting diodes. Hexagonal structure, each connected to 4 other type. 3. Interstitial nitrides. Formed with some transition metals. Nitrogen atoms fills out the interstices, corners, in the metal lattice. Non-stoichiometric equals interstitial nitride. Interstitial nitride equals inert, very hard, very high melting point, 2 H's, hard and high MP. Made by heating the metal in ammonia at high temp, heat metal in NH3 at high temp. Example, titanium nitride, remember, tin. Gold on color, used for color purposes. Used as a coating in some cutting tools. For titanium nitride, remember the two C's used as a coating and color. Hydrazine. N2H4. Bifunctional base, the second K value is lower than the first K value. Two salts are formed as a result of the equilibrium reaction, first is N2H5+ and other is N2H62+. Salts of N2H62+ are hydrolyzed back again to N2H5+, N2H62++ H20, N2H5++ H30+. Anhydrous hydrazine equals fuming colorless liquid. Hydrazine is commonly encountered as a hydrate in aqueous solution. Water is in aqueous solution. Hydrazine is a strong reducing agent in basic solution and itself oxidized to N2. Hydrazine burns exothermically, used as a rocket fuel. Nitrogen oxides. Naming characteristics. N2O equals dinitrogen oxide, nitrous oxide, atoms bonded in the order NN0. Linear molecule, isoelectronic to CO2. Nitrogen +1 oxidation state. Sweet odor. Dental anesthetic. Soluble in cream, propellant in whipped cream cans. No equals nitrogen monoxide, nitric oxide, odd no of electrons. Nitrogen in +2 oxidation state. Colorless. Reacts with O2 to form NO2. Readily forms nitrosonium ion No+. Even electron species, isoelectronic with CO. NO2 equals nitrogen dioxide odd no of electron. Bent shape. Nitrogen in the +4 oxidation state. Brown gas. Equilibrium with N2O4, the two NO2 are stable than N2O4. Loses an electron to form nitronium ion NO2+. HNO3 equals nitric acid. HNO2 equals nitrous acid. N2O3 equals dinitrogen trioxide anhydride of nitrous acid. Intensely blue-colored liquid or pale blue solid. Nitrogen +3 oxidation state. Pure substance equals solid. Liquid and vapor forms largely dissociated. N2O4 equals dinitrogen tetroxide nitrogen +4 oxidation state. Equilibrium favors the NO2. Solid equals diamagnetic, colorless. Only solid exists as N2O4, gas is largely dissociated into NO2. N2O5 equals dinitrogen pentoxide nitrogen +5 oxidation state. Anhydride of nitric acid. Unstable, colorless crystals. Reacts with water to produce nitric acid. Nitric acid and nitrates. Nitric acid made by Ostwald process, consumer of ammonia. 1. Ammonia reacts with oxygen in the presence of platinum gauze to produce nitric oxide and water. 4NH3 plus 502 to 4NO plus 6H20. 2. Additional O2 added to convert NO to NO2. 2NO plus O2 to 2NO2. 3. The NO2 reacts with water to form HNO3. 3NO2 plus H2O, 2HNO3 plus NO. Above reaction is an example of disproportionation, where one substance is both oxidized and reduced. Example, reaction of copper metal with nitric acid oxidation. Here, copper is oxidized and nitrate is reduced into NO2. Cu plus 2NO3, Cu2 plus 2NO2. Nitrate salts are made by neutralization reactions. HNO3 plus NaO, NaNO3 plus H20. HNO3 plus NH3NH4NO3. Large quantities of NH4NO3 are used as a fertilizer. Can undergo decomposition under the right conditions. 2NH4NO3 to 2N2 plus O2 plus 4H20. Nitrous acid and nitrites. Nitrous acid is unstable except in aqueous solutions. Can be prepared by mixing a metal nitrite with sulfuric acid at 0 degrees Celsius. BaNO2 plus H2SO4, HNO2 plus VaSO4. At higher temperatures, nitrous acid undergoes disproportionation. 3HNO2, HNO3 plus 2NO plus H20. Two resonance structures can be drawn. Nitrite ion has a bent shape due to the lone electron pair on the nitrogen. Sodium nitrite is widely used as a meat preservative.